What if science could finally prove Stephen Hawking's theory that there is a multiverse? In his final research article, he stated that there are an endless number of universes, each of which has various replicas of every person that lives on Earth. Well, now that we have the James Webb Space Telescope, which is the largest and most potent telescope ever deployed by NASA, and it has the capacity to observe 13 billion years into the past, could we prove if the multiverse is real? How has this telescope shown if Stephen Hawking's theory is accurate? And could this finally be a machine that will allow us to establish connections to a parallel universe? Keep watching till the end to find out. In his final research work, the late great genius scientist Stephen Hawking stated that there are an endless number of universes in which copies of each person on Earth live in various forms. The idea of a parallel universe is introduced in this. According to the Big Bang Theory, a Big Bang explosion caused our universe to form some 13.8 billion years ago. This resulted in the creation of planets, stars, solar systems, galaxies, and other heavenly or celestial bodies. One of the topics Hawking tinkered with toward the end of his life was the multiverse theory, the idea that our universe, with its beginning in the Big Bang, is just one of an infinite number of coexisting bubble universes. Hawking wasn't happy with the suggestion made by some scientists that any ludicrous situation you can imagine must be happening right now somewhere in that infinite ensemble. So in his very last paper in 2018, Hawking sought, in his own words, to try to tame the multiverse. He proposed a novel mathematical framework that, while not dispensing with the multiverse altogether, rendered it finite rather than infinite. But, as with any speculation concerning parallel universes, we have no idea if any of his ideas are right. And it seems unlikely that scientists will be unable to test his idea anytime soon. Multiple universes have been hypothesized in cosmology, physics, astronomy, religion, philosophy, transpersonal psychology, music, and all kinds of literature, particularly in science fiction, comic books, and fantasy. In these contexts, parallel universes are also called alternate universes, quantum universes, interpenetrating dimensions, parallel universes, parallel dimensions, parallel worlds, parallel realities, quantum realities, and more. The physics community has debated the various multiverse theories over time. Prominent physicists are divided about whether any other universes exist outside of our own. Some physicists say the multiverse is not a legitimate topic of scientific inquiry. Concerns have been raised about whether attempts to exempt the multiverse from experimental verification could erode public confidence in science and ultimately damage the study of fundamental physics. Some have argued that the multiverse is a philosophical notion rather than a scientific hypothesis because it cannot be empirically falsified. The ability to disprove a theory by means of a scientific experiment is a critical criterion of the accepted scientific method. Paul Steinhardt has famously argued that no experiment can rule out a theory if the theory provides for all possible outcomes. But to prove this false comes in the form of the James Webb Space Telescope. The James Webb Space Telescope is the largest, most powerful space telescope ever built. It was launched by NASA on December 25, 2021. It will allow scientists to look at what our universe was like about 200 million years after the Big Bang. The telescope will be able to capture images of some of the first galaxies ever formed. It will also be able to observe objects in our solar system from Mars outward, look inside dust clouds to see where new stars and planets are forming, and examine the atmospheres of planets orbiting other stars. This telescope is massive. The Webb telescope is as tall as a 3-story building and as long as a tennis court. It is so big that it has to fold origami style to fit inside the rocket to launch. The telescope will unfold, sunshield first, once in space. It costs $10 billion to build and launch in space. This telescope works on the principle of capturing infrared light that makes it look through dust clouds. Firefighters use infrared cameras to see and rescue people through the smoke in a fire. The James Webb Space Telescope will use its infrared cameras to see through dust in our universe. Stars and planets form inside those dust clouds, so peeking inside could lead to exciting new discoveries. It will also be able to see objects, like the first galaxies, that are so far away that the expansion of the universe has made their light shift from visible to infrared. It wears a hat to help block heat and light from the sun. The telescope can't function at high temperatures. It needs extremely low temperatures. It's not possible on Earth to create an environment for that low temperature, but it is possible in space. It's possible in normal conditions in space, as space is extremely cold unless a star is around that could produce heat, for example, the sun. But the Webb telescope's cameras are sensitive to heat from the sun. Just like you might wear a hat or a visor to block the sun from your eyes, Webb has a sun shield to protect its instruments and mirrors. The telescope's sun shield is about the size of a tennis court. The temperature difference between the sun-facing and shaded sides of the telescope is more than 600 degrees Fahrenheit. It uses giant gold-coated mirrors to see the universe. Space telescopes see by using mirrors to collect and focus light from distant stars. The bigger the mirror, the more details the telescope can see. It's very difficult to launch a giant, heavy mirror into space, so engineers gave the Webb telescope 18 smaller mirrors that fit together like a puzzle. The mirrors fold up inside the rocket, then unfold to form one large mirror in orbit. Why are the mirrors made of gold? A thin layer of gold helps the mirrors reflect infrared light. Now we know what a multiverse is and what is James Webb Space Telescope. Now let's look at how the telescope has the potential to prove the theory of the multiverse. The universe is thought to be around 13.8 billion years old, and the JWST will be able to observe light from the earliest stars and galaxies close to the Big Bang. The JWST is an infrared telescope, meaning it uses infrared radiation to detect objects in space. It can observe celestial bodies such as stars, nebulae, and planets that are too cool or too faint to be observed in visible light. That is, what is visible to the human eye. According to NASA, infrared radiation can also pass through gas and dust, which appear opaque to the human eye. This is different from the world-famous Hubble telescope, which sees visible light, ultraviolet radiation, and near-infrared radiation. According to a report conducted by an independent review board in 2018, there were 344 single-point failures, or steps that needed to work for the mission to succeed. However, the telescope was tucked inside the nose of an Ariane 5 rocket and launched safely from the European Space Agency spaceport in French Guiana in December last year. It separated from the rocket after the launch and began unfolding. According to NASA, about 30 minutes after the launch, the first deployment took place as the solar panels unfolded so the telescope could get power from the sun. Because of JWST's capabilities, many astronomers are vying for time with the telescope. The Space Telescope Science Institute, which oversees science operations on Hubble and JWST, had sent out a call to astronomers for proposals on how they'd like to use James Webb, with 6,000 hours of observation time up for grabs. The lucky ones have now received approvals for their projects, and we look forward to the wealth of knowledge they will enrich us with. There's plenty of time for the JWST to unlock the deep secrets of the universe, with about 20 years of operation guaranteed by the amount of fuel aboard the space telescope. With the JWST safely delivered to its location about 1 million miles away from the Earth, it is time to confirm one of Hawking's most intriguing theories, the multiverse concept. However, despite being his last work, the paper was actually a final look at one of his earliest theories. In fact, if the JWST eventually helps prove the existence of the multiverse, it will make the scientists behind it likely candidates for a Nobel Prize. However, since Nobel Prizes cannot be awarded posthumously, Hawking would be ineligible to receive it. But it would be interesting to see what new planets the telescope will discover where life can be possibly found. This revolutionary telescope may prove many beyond imagination theories by great scientists, and the multiverse theory by Stephen Hawking is just a simple example of it.